There are a number of ways to calculate scale factor and apply localization. The method chosen is based on various things, including the size of the site, directional orientation, and more. In this video, we will look at a very simple example of one method and apply a localization in TBC. To get started, we need three things: a blank TBC drawing, which was created using the NCDOT template, the JXL file that has the VRS observations, and the averaged EDM distance between the GPS points. We will start by dragging and dropping the JXL file into the drawing. By clicking the Vector button in the Home tab, we can review RMS error and other precision criteria. Assuming the vector data is within tolerance, we can close the spreadsheet and return to Plan View. Select Measure Distance and measure between the two GPS points. Now, get the averaged EDM distance between the two GPS points. This is how I like to think about calculating scale factor on a small and simple job such as this one. Our GPS points were observed in unadjusted grid. Because of that, the VRS distance between them is slightly skewed. However, we know the true distance between them because that true EDM distance came from our total station. In order to get the VRS and EDM distances to match, we have to multiply that skewed VRS distance by something in order to get the true EDM distance. That something is scale factor. If we fill in the equation with our known distances, we can do some simple algebra to find the scale factor. Now that we have the scale factor, we are ready to localize. Let's get back into TBC and note that we are currently in grid mode. In the Survey tab, click Local Site Settings. Change the coordinate type to local. Then click inside the latitude box and erase the question mark. Click on the point that you want to localize around. Check the box for Use Ground Coordinates. The field below Ground Scale Factor is where we will type in our calculated scale factor. But before we do that, let's do a quick check on that number. Check the box beside Compute Ground Scale Factor. Here we can see that TBC's calculated number is very close to ours. We will uncheck the box and type in the scale factor that we calculated, then click OK. In the bottom right, we see that the description is changed from grid to ground. This means that our job has been localized. Let's create a point spreadsheet to verify that GPS 1 has shifted slightly. If we compare the new TBC coordinates to the original VRS file, we can see that GPS 1 has shifted 2 to 300ths and GPS 2 is in its original location. The horizontal coordinates for GPS 1 and 2 are now finalized. They can be exported and used as control in the traverse adjustment. Once the elevations have been adjusted with the level loop data, the control file and the Pantex file can be generated and saved in your project directory.